We're making a new fixturing tools for making our boring bars, and I've been sharing with Jeremiah, teaching him on some of the machining, and he's been doing a good job. And on these blocks, he's milling this 1/8 inch cut on the side of the part over here. He's milling that. It's about 445 thousandths depth of cut. We're taking 30 thousandths at a time, just taking it easy. But one of the things that I mentioned to him, and as I train him, I'm telling him that he needs to learn the language of these machines, because they will actually talk to you and communicate to you if you know how to listen to them. And one of the things that I've done in the years past was I pay attention to the noise that the machine's making, the noise that the cutter's making as it's cutting in the part. I pay attention to when I'm cranking on the dials on a manual machine. I'm feeling the vibrations in that. I'm listening to the sounds. I'm seeing the chips, how they're flowing out of the cut. So I'm using my eyes, I'm using my ears, and I'm using my sense of feel. And that way I can tell when things are going to probably start to get a little bit ugly. And so anyhow, we have 7 of these. I've made one of them that's complete already. We got 7 more we're making, so we're going to have 8 altogether. And so Jeremiah is doing all the work on these slots. And the end mill we started with, I knew was a little bit dull, and it worked out great because he started with that, and we're almost finished with him. And I'm drawing some stuff up on CAD in just the room over next to him. And I could hear, just from where I was hearing there, I knew that end mill was going to go out pretty quick. And sure enough, the end mill broke. And so I told Jeremiah, I said, okay, now you felt how it felt. You heard the way it was sounding. You saw how the chips were not evacuating the cut very good, weren't being flinged around as good. And so you noticed all that. And so I said, when we put a brand new end mill in, I want you to pay attention now to what it looks like, to what it sounds like, and what it feels like in the vibrations in the handles. And so he could, on that lesson, he just learned quite a bit. Well, what was the difference? I mean, you could really tell the huge difference in that. Yeah. And this is what's going to make you probably a cut above most machinists when you start getting and developing that feel for a machine. He could easily stop the machine if he wanted to at that point, change the cutter before it broke, but it's a little 1/8 inch cutter. We would have had to throw it away anyhow, and so I was going to let him run until it broke, and this way it gave us a good lesson on listening to the machine and communicating with that. Hello everyone, it's been a while, about a month I believe, since our last video. Adam and myself have been pretty busy. We had some projects that we had to get done around the house, and I know Adam's been kind of busy here at work the last few weeks. And so anyhow, we finally got a chance to shoot a video today, and what you have seen just a moment ago was a little fixture that I've made so that I can make these bushings. And these bushings, they have a 1/2 inch OD and a 3/8 ID. And so here I got some 3/8 drill rod that making these bushings for. You make 2 of them at a time. I have to make a number of these. I have to make 16 of them because this boring bar fixture that I'm making, the units that I have here, little clamping devices, they hold the drill rod, the 1/2 inch drill rod. You can throw it into this fixture, lock it down, and you could do all your mill work on this fixture for this side of the bar. Actually, the first thing I do is take a 1/2 inch end mill, and we'll do a video on this pretty soon. I take a cut there, I pull this out, flop it around, do the same thing on the other bar, and then we come to this side and we cut our relief area, and that'll be halfway down on the bar. We flip it around, and then you can do that. And by having some identical parts over here, we can do this on 8 boring bars at a time, and we're making double-ended boring bars so that you have a pocket on this side and a pocket on this side. And so you got 16 pockets. And so what happens is, in the past, we always had to run all of our tools, your 1/2 inch end mills, your 1/8 inch end mills, your taper end mills. You had to set all your heights separately. Now we can streamline this and just use the same end mill, do the operation on 8 bars, and swap out end mills, get your depth set, do the operation on 8 bars, and so forth. It should speed making these up quite a bit. But anyhow, I was kind of inspired with the unit you just saw over here, because we're making some of these bushings, and I obviously put more time into making that little fixture than it was worth for doing these 16 bushings, but we'll probably be doing more stuff like that in the future. But I've been watching Randy Richards. He got some videos that he's done on his turret lathe, and he makes these little scribe tools, and he sent me one, and these things are pretty neat. And the videos that he's made showing and demonstrating the turret lathe and how it works and how fast he can put these things out is quite amazing. I've heard of turret lathes, I've really never seen them work, and so it was kind of nice that Randy did those videos, and so I can actually see them in action. But it kind of gave me a little bit of inspiration for, I thought, I wonder if I can do something like this on the mill. I wonder if I can have a facing tool, some center drills, and if I can, with a parting tool, if I can actually make these bushings, they're about 2 1/4 inches long, if I can whip these things up pretty fast. And so this is the 4th one. We have 18 altogether that we got to do. And what these are going to do is it'll let us put our 3/8. I'm just going to put it on one side right now. There we go. It'll let us hold the 3/8 bar in the same fixture. And but anyways, and then we can clamp down on this, do the 3/8 bar, do the pocket. So we're set up. We can do the 1/2 inch bars, the 3/8 bars. We're still working on right now. I got to do a little bit more work on these bushings. I got to cut half of it away for a certain section, and then I got to cut a split in there so that this can clamp around. But I think that's going to work real nice. So instead of having to make separate units here for the 3/8 bars, I don't have to reproduce this work all over again. The bushings can be a whole lot simpler to make. And we're going to start out with a 1/2 inch and 3/8 bars in a couple different configurations, and we'll probably make other sizes in the future. But here's one of the bars that we made using it, this particular fixture. We're using the Sumitomo insert in their screw, and one of the things that you'll find when you're doing boring bars, I'm designing these bars around an insert that I like, but there's other people, they have inserts that they like that are different than this. So we're going to make different variations of this. This particular insert is an 1/8 inch thick. A lot of them inserts, if someone wanted a 1/2 inch bar and a 3/8 bar, well, if you put an 1/8 inch pocket in a 3/8 bar, you only got a 1/16 of an inch for your threads down there, and it's very weak. So they make these inserts. They make this exact same insert, but they make it in a 95 thousandths thick, I believe it is. And some of the inserts that we use at my full-time job, that the guys use that they provide for them in the vending machine, they're like 95 thousandths deep. So when I make these bars for some of the guys at work, they want to use the inserts that are provided by the company, the screw that's provided by the company. That way they don't have to spend any money on inserts or the hardware. So we're doing this in 2 different configurations, well actually about 3 right now. We're going to use a Sumitomo insert with a 3mm a screw, and then we're going to do a Sumitomo insert with a 95 thousandths thick insert, and it's going to have a, I believe, 2.5mm screw. We're going to do another bar that we use the 95 thousandths thick insert, but it have a 440 tap, which matches the hardware and inserts that they have at our full-time job. So trying to make a bar that can encompass as many inserts as you can is kind of difficult, because you got different sizes on the thicknesses, and you got different screws, different threads, and so that's kind of a challenge there. But we're going to start with these few configurations first. We're hoping to offer these for sale here in the near future, and so if you're interested, just let us know. The pricing, we're looking at now 3/8 and a 1/2 inch would be the same, because of the cost of the material is extremely close. The labor is going to be about the same. We're going to make a version that is hardened to about 50 Rockwell. These are made out of A2 drill rod. We plan on black oxiding them. If I remember right, I think A2 does black oxide pretty nice. And so we'll provide one that's black oxided, heat treated, with one sample insert from Sumitomo with the hardware, the screw, and we're looking at about $80 for that. We also know there's people, we've already ran across it, that they don't want the bar hard, they want it soft. And in one particular case, Adam and myself, we have a friend that Adam works with, he wanted us to make him a bar, and he wanted 3.5 inches long, and so we had another bar sitting around with the pocket. We didn't mess it up, but it was a size that just wasn't going to work on the one side, so it worked out perfect. We just set that up and cut that off, and what he's going to use this for, I believe he's wanting to put it in a boring head. You can make a 3/4 inch bushing, a split bushing with a 1/2 inch ID, and then you can use a nice boring bar like this in a boring head. So there are some people out there that they might want the heat treat different, so we'll sell a soft bar. They may have their own oven. They may work at a place that have their own ovens. They may work at a place where they can send it out and piggyback with the companies. And so we'll sell the bar and just the screw, and we're looking at that as probably $70 for a double end. And so anyways, if you're interested, just stay tuned. In the future here, we're going to start trying to tool up on these things and make them in batches, and hopefully we can provide a nice tool for anybody that's interested. Well, thanks for watching. We'll see you next time.